And our last question, question 10, we got a donkey, and it's got a weight of 2,500 newtons. Happy with that. The area of each hoof, and they're being careful to say, is 0.022. I'm going to count. There's definitely 4 hooves, so I'm going to need 4 lots of 0.022. And it says calculate the average pressure, and I just need to use that. So 4 hooves is 0.088 area, and then P equals F over A. That's our Professional Football Association. And then we've got that. It doesn't ask us for any significant figures or to go to a number of decimal places, so we can just leave it as that. Next one, we've got the shape of a camel's hoof versus a donkey's hoof, and we can see this has given us a greater area, and therefore it's less likely to sink into the sand. So camel and donkey have roughly the same mass. Explain how its shape helps the above a donkey on soft ground. So camel's hoof has a larger surface area. Now it's the bit we said we've got the same, so we're going to always make the link to the equation PFA. If they've got the same force downwards, if that goes up, this goes down. Okay, so the next part is, so there's less pressure as with the same weight, the force is spread over a larger area. Don't ever say the pressure is spread, it's always the force is spread, because we can see the pressure is the force over the area. Pressure is not a pressure over an area. So just be careful with your wording on that, but that's quite easy. The next one, they carry out an investigation to see how pressure varies with depth, and they've got a mobile phone, and they've got a little pressure sensor, and they collect these, and it says, plot the missing 2 points. So you just have to go in there, find things. Now, you know me, I've got terrible stigmatism, so graph work's awful. So you're just going to have to find your values, 0.1, because that's missing there, and find 99.7. 0.25 was missing, 101.15. There we go. Then draw your line of best fit. So straight line through the points, making sure it goes through the through the axes, so that we have an intercept. Okay, next part. Which of the following represents pressure? We can see we've got a straight line, so this is y equals mx plus c. So that's going to be that one there. Use the graph to predict the pressure at the surface of the water. Here's atmospheric pressure. Here's the water pressure, and the two combined gives us the total. Actually, if I wanted the water pressure, I'd have to take this off every single time. So this is the total fluid pressure. So there's atmospheric pressure, and in physics, intercepts are important. So it's asking you to go and look at the intercept. So read that off, and we've got 98.7. The student repeats the investigation using seawater and draws a graph. Seawater is more dense. Compare the graph for seawater. So, well, if it's so we know P equals H rho G. So if that goes up, that goes up. So the pressure will be greater. So if that was the line before, it's going to be a steeper line. But they're both intercept in the same place. We've changed the density. We have not changed the atmospheric pressure. Okay, and that's that. Tricky one at the end. That they both intercept at the same place was missed by a lot of students.